Reusability means that there needs to be intelligence within the charm, within the framework for the charm, so that the charm can know about its environment and can make decisions at deployment time based on this environment. It also means that we want to have all the function to handle scaling included within the charm, so that once you've expressed this knowledge, this DevOps knowledge, once you've distilled it into your charm, then it is reusable for anyone without having to understand again the internal logic of the service you're trying to expose. One thing that we really didn't want to do was to impose a specific programming language when expressing a charm. And the framework for Juju is an event-based system, but for each event, you can define whatever executable shall be called to handle the event. So if you want to write a charm in C, I wish you good luck, but you're enabled to do so. If you want to write it in Bash or in Python, or using a configuration management tool, such as Puppet or Chef or CF Engine or name it, you are welcome to do so, as long as this environment is something that can be pulled from the repository of the platform at the time of deployment. We are fine with it. So internally, how does this work? So as I told you, the basic notion of Juju is to define charms, which are the atoms, the representation of the service. And these atoms can be instantiated by the Juju environment one or many times. However, a service all by itself doesn't make a lot of sense. A service needs to be collaborating with other services. And we need to be able to express dependencies. For example, I have a cloud application that depends on a load balancer, and that depends on a database, an SQL database. And I will express, whenever I can, this with an abstract format, not specifying exactly, oh, I want MySQL or I want Postgres. I will just say SQL database if I can. And at the time of deployment, I can choose to resolve this dependency for a load balancer, for example, by HA proxy, and the dependency for an SQL database with MySQL. I will establish the link between the two by satisfying these dependencies. What's interesting in this model is that multiple charms can provide the same resolution for a given dependency. So for example, I have a package called HA proxy, which I started to deploy here, but I can decide to replace it by another one named Varnish. And because the interface between these services are doing the same thing, we can abstract this notion of load balancer and make it completely independent of the underlying code in my cloud application. I could do exactly the same thing, replacing MySQL by Postgres. So if you followed me so far, what you will understand is one thing that is very important in Juju is this relation. This relation carries all the configuration information that is necessary to allow my cloud application to talk with an outside requirement, a service, and vice versa. And this relation is what is allowing me to scale any component in a Juju environment completely independently, just by a single command called Juju add unit, and another one to remove a component called Juju remove unit. And it's because we know within Juju of the existing relation between the different components that we can provide this automated scaling mechanism. For example, in a normal world without Juju, every time you would have to remove an instance of your cloud application, you would have to modify the configuration of your load balancer to remove this IP address from it. Or every time you would have to add, you would have to modify the load balancer to add the IP address to it. This is something that is completely automatically handled for as many relations as you want. So really, the core of what we deliver in Juju is this capacity to express dependencies between services, to define all the configuration for the services, and to abstract the notion of relation with its configuration so that scaling is not anymore an issue. This is an example of a wiki deployment where I think there's a little laser pointer here. I don't know how to activate it. Maybe that's it. Yeah. So here we've got a wiki that, oh, by the way, this graph is produced automatically by Juju. Actually, we produce an output from the status comment that can be interpreted into this graph. And here we've got a demo wiki that has been instantiated on 2 nodes that is talking with a load balancer that has been instantiated on 1 node, which is talking to a couple DB, the main database and its slave. And here we've got a memcache implementation. And of course, in whatever is in any of these boxes can be independently scaled from each other box to respond to a given demand. What we are not doing in Juju at this time is determining when to scale. So that still is something that you have to handle through an external service. But we give you a very simple way to express how your services should scale and use existing services to scale with it and have very, very simple commands such as Juju deploy, Juju add unit, Juju remove unit to manage your infrastructure. And this is how we are now talking with Compatible One and specifically with Jamie on how we can connect this technology, which does make sense at a given cloud infrastructure, and which we think could translate very well from a core definition to a Juju implementation. No, that's not how I'm moving my slides. So I wanted to keep it short. I was only given 20 minutes, so I think I'm just at it. If you want more information, of course, I'm here a little bit more until after lunch. So please do not hesitate to come talk to me. There is plenty of information, documentation on juju.ubuntu.com. There are also videos, blog posts of people that have written charms that give their experience on how this has been done on cloud.ubuntu.com. Thank you very much.